Intro to reactions, chemical reactions. So first thing, we're going to go back into chemical versus physical kind of thing. So the signs of a chemical reaction, which chemical reaction is the same thing as a chemical change. 4 signs to go back over here. Color change, remember, has to be dramatic, does not include any kind of dye or fading, so it's not like a shirt fading from a dark blue to a light blue over time. It has to be a dramatic change. Production of a gas, the way you're going to see it is you're going to have bubbles. Now this does not mean that you blow in a straw and have bubbles in the water, okay? Production of a gas means it's going to do it on its own. You don't have a pot sitting on the stove and it starts to boil. That is a phase changes. Phase changes are not a chemical reaction. It has to do it on its own without any kind of heat source. Precipitate forms, this is just a fancy word for solid mixing or solid forms when 2 liquids are mixed together. Again, it's not that you put it in the freezer or anything like that. It happens by itself. Change in heat and temperature, does it on its own, no heat source. So you mix 2 chemicals together and all of a sudden it's getting too hot to hold. That is an example of that. Law of conservation of mass. This is when mass is neither created nor destroyed in a chemical reaction. So if I start off with 4 plus 32 grams, so that equals 36. If I start off with 36 grams, I'm going to end with 36 grams. Mass doesn't just appear or disappear. Okay, so if you start off with 36, you end with 36. So the total mass and the number of atoms stays the same. So I have 4 hydrogens, I end with 4 hydrogens. I start with 2 oxygens, I end with 2 oxygens. The only thing that's happening is the atoms are rearranging. So in the example in the picture here, the hydrogens are kind of attached to each other, the oxygens are kind of attached. When hydrogen and oxygen react, you end up getting water molecules. The 2 hydrogens bond with the oxygens. A basic chemical reaction is the reactants react to produce the products. Reactants react to produce the products. So on this side of the arrow you have reactants, on the right side of the arrow you have your products. So it's always reactants to products. Reactants react to produce products. Products are what's being formed. So if you have a product of an assignment, that is what you're ending with. Some symbols that you need to make sure that you know and recognize. The arrow means to produce. That's why you're going from reactants to products, because you're producing the products. The plus sign means exactly like it does in math. It's plus. You're adding 2 things together. The next few are your states. So S, L, and G, solid, liquid, and gas. AQ, now this is a Q. I don't know why it looks like an A there. So AQ stands for aqueous. This just means that it's dissolved in water. So for example, if I had NaCl with a little AQ like that, that is salt water. This triangle over an arrow just means it's been heated. Now, if I give you a chemical reaction, you can tell a lot out of it. You can tell these 3 things here, okay? You can tell how many of each thing. So for example, here, this tells you you have 2 hydrogens. No number here means you have 1 oxygen. Here, you have 2 waters. So it tells you how many by looking at the coefficient. Coefficients are the big numbers out in front. So you have 2, 1, and 2. Then it tells you of what. It tells you the chemical formula. So you have H2, you have oxygen gas producing water. Then, like I told you in the previous thing here, it shows you the state, the physical state. So this G tells you that this is a gas, and a gas. So in all 3 they are gases. Okay, now this here, you're going to need your periodic table. Periodic table, these are your diatomic molecules. This just means that they, when they're together, they always are paired together. They can never be alone. You always have that one friend that always has to be with somebody all the time. These are these elements. So what's happening here, is these 7. You need to label them, star them, do something in on your periodic table where you know that they are not polyatomics. They are diatomics. Di. Okay, so N, O, F, C, L, B, R, I, and H. These are diatomics. What that means, when they're by themselves, they have to have a subscript of 2. So N2, O2, F2, Cl2, Br2, I2, and H2. They cannot be by themselves. So when I say oxygen gas, that is O2. Nitrogen gas, N2. Okay? Now, what's going to happen next is I'm going to give you a chemical reaction, what's called the skeleton equation, and you have to figure out what coefficients go there in order for it to obey the law of conservation of mass. The first few slides here, we're going to go through the steps, and it might not make any sense whatsoever, but then we're going to do some examples and things should start clicking. So step 1, you're going to have the unbalanced equation. Step 2, count atoms on both sides. You'll see when I get there. Step 3, add coefficients. So these are the big numbers out in front. You always do coefficients times subscripts to get how many atoms there are. Reduce if possible, double check. Okay, so count atoms, put coefficients, reduce if possible, double check. Now, this right here, this slide is important. Now you don't have to write it all down, just the key things that I have here. So first off, balance one element at a time. Don't try to balance hydrogen and oxygen, all of them all at the same time, okay? You do one at a time. Look at them step by step. Update all atom counts every time you add a coefficient. So every time you add a number, recount. Most common mistake is to put numbers and keep on moving and forget about what just happened. Okay? If an element appears more than once, balance it last. So if an element appears twice on one side, save it for the very ending. Polyatomics do as one element. So for example, SO4, you do not have to split it up into S and O. You just keep it as SO4. Okay? So let's go ahead and jump on in here. All right, so NaBr plus Cl2 produces NaCl plus Br2. Remember, these are your reactants, these are your products. Down the middle, when I say down the middle, where the arrow is, you're going to list the elements in that reaction. So we have Na, Br, and Cl. So down the middle, list your elements. Now what you're going to do is you're going to count atoms. So tell me how many are on this side and how many are on this side. So Na, 1, Br, 1, chlorine, 2. So where do those numbers come from? It's a subscript that's attached to them. So no subscript means 1. There's a 2 there with chlorine, so 2. Now we're going to do the same thing on the right side. Now make sure that these numbers match with this side and whatever numbers go here on the right side. So Na1, Br, 2, chlorine, 1. Now right now this does not obey the law of conservation of mass because it says you have 1 Br and how you suddenly have 2. It's not like it came from nowhere, so you have to balance it. When you go to balance it, you're going to add coefficients. You can only add coefficients in front of the compounds. You cannot shove subscripts. You cannot change subscripts. The only time you can put a number is out in front of the substances. That is it. Okay? So you're going to do it step by step, one element at a time. Na is already balanced, Br is not. You have 1 over here, 2 over here. You're typically going to put the coefficient on the side that has the least amount. So the side that has the least amount. So bromine has 1 and 2. So which side has the least? This side. Now, you don't care about this because right now we're balancing Br, which is over here. Remember, you can only put it out in front of the entire thing. You cannot shove it right there. And you're going to ask yourself the same question over and over and over and over again. You're going to get so bored with it, or you're just going to click and you're going to understand it. So you're going to ask yourself, what times the subscript equals what you need on the other side? So what times 1 equals 2? And your answer should be 2. That's the coefficient that goes there. So what times the subscript equals the other side? So you put a 2. Now here's where the step comes in. Every time you add a coefficient, you're going to recount because what's happened here is this 2 distributes to everything that it's in front of. There's 2 Nas and 2 Brs. So you need to change these numbers. Okay, so Na becomes 2 because it affects everything that it's in front of, and Br is 2. So bromine's balanced. But in the process of balancing Br, we now have Nas all messed up. We now have 2 over here and 1 over there. So again, you're going to put the coefficient on the side with the least amount. So now we have 1 over here. Ask yourself that same question. What times 1 equals 2? So what times a subscript equals 2? And your answer is 2. Recount. Na is changed, and in the process, it changes Cl to 2. Does it change Br there? No. Once you hit that plus sign, it doesn't change anything else. Now if you look, your numbers mirror each other. If they mirror each other, you are done. Your final answer is what's up here. What's down here is showing work, which you always have to do. So here's your answer, 2. If there's no number there, that means it's a 1. So 2, 1, 2, 1 for your coefficients. Let's try another one. Okay, this one's going to get a little bit trickier here, but it's still going to be the same process. So down the middle, we have Al, Cu, and Cl. Elements down the middle. Aluminum on the left, 1. Copper, 1. Chlorine, 2. On the right, copper, 1. Aluminum, 1. Cl, 3. Okay, now remember, you can only add numbers in front of the different substances. Aluminum is good, copper is good, chlorine is not. You have a 2 and a 3. Typically, you're going to go to the side with the least amount, right? And you're going to ask yourself, what times 2 equals 3? Roadblock. Is there any whole number times 2 that will equal 3? And your answer is no. So what you're going to do now is you're going to find the number that both 2 and 3 go into. What do both 2 and 3 go into? And your answer should be 6. That is going to be your magic number. Okay, so if you get to a point where there's nothing, there's no whole number times the number to get the other side, you're going to use the, I think it's least common denominator or something like that, least common multiple, one of those math terms, I'm sorry. So what times 2 equals 6? That's going to be the magic number, and your answer is 3. Distribute. So chlorine becomes 6 because 3 times 2 is 6. Copper, 3 times 1 is 3. Okay, now we're still not done with chlorine because we got 6 over here, but now we still got this 3 over there. So we still got to fix chlorine. Don't move on to copper yet. Take it step by step. So chlorine, what times 3 equals 6? And your answer should be 2. And you distribute because you don't want to just move on because then you might get messed up. If you just go ahead and put a 6 there and move on, you're going to get it wrong. So chlorine becomes 6 because 2 times 3 is 6. Now it also changes aluminum. So you get 2 because 2 times 1 is 2. Now, chlorine's good. In the process of fixing chlorine, we've messed up aluminum and copper, so now we got to fix it. Aluminum, we have 1 and 2. Where are we going to put a coefficient? On the side with the least amount, so we're going to go over here. So what times 1 equals 2? So you put a 2 and fix. That is good. Copper, we have 3 and 1. So what times 1 equals 3? And there you go. Let's try another one. I'm going to skip to this one here. All right. What's different about this one? This one looks super long and hard. It's got polyatomics sitting in there. A tip that I'm giving you that was not on that previous sheet, if you have a polyatomic and there's no parentheses around it, put it there. So for example, OH, NO3, those parentheses are gel cells. You are not allowed to go in those gel cells. You cannot look at that 3 whatsoever. Do not look at it. Okay, so when we list down the middle, we're going to put Ca, parentheses, NO3, Na, parentheses, OH. It's exactly how you list it. You don't have to split up the polyatomics. You keep them exactly the same. Okay. And now we're going to count the atoms on both sides. Remember, you can only put coefficients directly in front. Then we're going to count. So calcium on the left, 1. NO3, now this is where you're going to look outside the parentheses. So for NO3, it's going to be 2. Don't look inside the parentheses. Those are off limits. Okay, Na, 1. OH, 1. Right side, Ca, 1. There's no number there. NO3, now there's no number. That means there's 1. NO3 with no number on the outside is 1. Do not look at that 3. Most common mistake. Na, 1. OH, you're going to look at the number on the outside of the parentheses, 2. Okay, so when we add coefficients, calcium's good, nitrate is not. We have 2 and 1. So where are we going to add a coefficient? To the side with the least amount. So what times 1 equals 2? And your answer should be 2. Distribute. So you get 2 and 2. Nitrate, good. Sodium's now messed up. We got 2 over here, but only 1 over there. So what times 1 equals 2? The answer should be 2, and distribute. So 2 and 2. Okay, so now you should see the numbers are mirrored. You're done. That is it.